Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage, Glen Ellen, Illinois. And this homework example that we're going to follow today is an extension of the activity that you did earlier in the week. So we're dealing with integer multiplication, division, and modulus operations. So I guess technically if you did your activity right, you shouldn't be doing too much of that, generally speaking, like writing out the nitty-gritty details, and now you'll be writing code that uses that functionality that you've generated previously. So again, I have the previous activity video, go see that if you need assistance to understand where this code comes from for multiply function, this code comes for division function, and where this code comes from for the modulus functions that you see, because this is exactly removed from the activity. The goal of this homework assignment is to generate this string of series of numbers, and to do that you need to write this code down below. And I believe I did everything where you don't have to do too much other than just follow step by step to get the job done. So let's go ahead and start. Let me get rid of the main stuff here that I had from previous. And so there's my system pause down there, so I can get, I don't have to worry about this stuff here. I just have to worry about all of this stuff up above. Okay, so let's see. I'm going to move 1 into the EBX register. And so I'm going to do a while loop. So remember how while loops work. So I have again. I have two labels. One unconditional jump. And then what I have to do is do my check here, right? So, and then then I'm going to just go through the motions here. Let me just say jump again. Let me put a comment here. This is the outer loop, because we're going to have two loops here, right? You see how this goes here? There's the outer loop that's looking at this, and then the inner loop that's looking at that. So right now we're going to compare, and we're going to compare EBX to 1400. And then let's say this is to keep in the loop. How do we get out? Less than, the opposite of less than again is greater than or equal. And so that's how I get out of this loop. And so that is all I need to handle to get the loop going. And right now it would be an infinite loop since nothing happens to EBX or anything like that. And so let me just borrow this. Sorry, if I make this the slightest bit smaller, everything just dies when it comes to formatting. And it's unfortunate, but that is how it goes. Okay, so there's my while loop. Bring this over. Okay, yes. Okay, fine, fair enough. Let me just say, just so we know where we're coming from, EBX equals 1. There's my while loop, and let's continue on here. Okay, so now I'll have to move the EBX register into EAX register so I can call the right int. And then I'll have to move a comma into this guy here so I can call right char. And then I'll move a space so I can call right char. So, a lot going on there to do these 3 lines of code, but it gets the job done. Oops, wrong one. Make sure I'm doing things right. There's that. There is this, and here is that. All right, so there we go. So this should still infinite loop because we're never modifying EBX yet, which is part of our code, so it'll just print garbage. +1, +1, +1, +1, +1, +1, ++++++++. I guess technically I could use right dec or des for the unsigned, so I don't have to put that leading positive sign there all the time. Okay, so now that's all finished up, and now we're ready to move on to this stuff here. So a couple lines of code here. This is easy stuff. Move 1 into ECX, move EBX into ESI. Continue on here so that we're commenting as we go. Trying to obey best practices. Always trying, very trying. Okay, so that takes care of that. And now we're ready to do the next while loop. So, how does a while loop work? You remember, we already just did it. The only problem is we already have labels for again and done. So I'll just say, I'll call it inner again for inner loop. I don't know why, I don't know where my, hello? I don't know what's going on. I'm not allowed to backspace. I don't understand what's happening. My computer just hiccup. I don't know. And then I'll call it inner done. And since this is a loop again, I have to do a jump, unconditional jump to inner again. I don't have anything that goes before it because I already did the work for that. And so jump to inner again, jump to done, and then this is where this gets handled. So I compare ESI to 0 and jump if, now the opposite of greater than is less than or equal. Inner done. Okay, so that handles the while. I put that here in the right place. That handles that while loop and everything else that goes with it. And now notice here, the only thing we do between this loop, this jump, oh no, wrong place, right here. When we jump out of this inner loop and we come out, there's only one step right here before we jump back to the outer loop. And that's this guy right here. And for this, I can just do an add. And I say add EBX comma ECX. That's this guy right here. I'm hoping I'm doing this right. There's no, until it's all said and done, kind of a lot of moving parts here. But now coming back in here, right here, is where we just need to fill in the rest of this gap, and then everything should come into place. And if I did everything right, everything will work right. Okay, so I'm going to move into the EAX register ESI. I'm going to move into the EBX register at 10. I'm going to call modulus. And then I'm going to move into the, into the EDI register, whatever was in EAX. 4 lines of code in assembly, not even counting the function itself, to do this one thing. Because remember, we're putting the first parameter is EAX, the second parameter is EBX. We call the function, and then the return value, which is an EAX, gets put into whatever we want. Okay, so there we handle that line of code. And now we do our if statement. So if EDI does not equal 0, so let's do a compare between EDI and 0 and say, how do we get out, right? I'll just call this nothing. And you say not equals, the opposite of not equals is equal. So jump if equal to nothing. Otherwise, go inside here and do this, which is 4 lines of code, just kind of like we just did a minute ago here. Let me just find my JE to nothing. Otherwise, do the compare EDI to 0 right here. Yeah, the cursor got lost there. Okay, so move into the EAX register ECX, move into the EBX register EDI, call multiplication. Oops, call multiplication, and then move the result from EAX into ECX. Okay, so that handles that. Then we hit the nothing because we're not doing anything if this comes around. We fall through 4 lines of code. So let's see. Let me just pop this in here. So here's this guy. All right, there's my comparison. And then here is my setting of that. Okay, and now the last thing here is when I fall out of here and when I come to nothing, before I jump to the inner loop again, I have to do this one last line of code, which is 4 lines of code again on my end. And I think it just might work. I don't know. And if not, then I'll have to fix it up. What is wrong, right? We'll have to look through everything. But let's see. I need to move into the EAX register ESI. I'll have to move into the EBX register 10. I'll have to call division. I don't even know what that is. And then I'm going to have to move into ESI, whatever the EAX register. And that, let's see what happens. Let's see if what values are we supposed to get this guy here? 1, 2, 4, 8, 16, 22, and so forth and so on. And I do not get that. So I'm going to have to do some debugging to figure out what I did wrong and show you guys how to fix all of that. What did I do wrong along the way? is there ever really such a thing as an infinite loop? Because eventually everyone gets tired of looking at the same numbers over and over and over again. And so I figured out what's going on, and it's, we didn't do anything wrong with the code itself. All this code is actually correct. It's just we have a race condition. It's not really a race condition, but it's just we're using these registers in too many different ways, and they're conflicting with one another at this point. Because if you look to see through our main function, we're using EBX to hold one of the values of, we're testing and printing out, oh, it's a 1, oh, it's a 2, oh, it's a 4, or oh, it's an 8, whatever. That's the next value in the list or of the sequence. And so, but what happens when we get down to here, and we're using either the modulus, the mult, or the division functions, what's happening is we're blowing out this value to being replaced by whatever the second parameter is, right? We're using it in the main. We're also using it here. We're doing imul EBX, idiv EBX, idiv EBX. So the problem is inside our code, everything's going to heck as soon as I go down to here and I say, change this. And then we're never replacing it. So the key here is, there's many ways. You could keep track, or you could move this over into a different register. Let's see, we're using EDI, we're using ESI. It gets tricky because we're using pretty much all the registers are being used at this point. And so it can be quite a bit tricky. But what we can do is something like this, where we can do a push of EBX. We can take the value currently in EBX and push it onto the stack right before I blow it out. And then when I'm done with calling my function, I'm just going to go ahead and put it back. And you're going to see I'm just going to do this for each time inside of my function here, right before I blow it out, and right after I'm done using it, for all three things. And then what happens, when I run my code now, it's like the magic has happened, because now I get the result that I'm expecting to see. And you can see that now all the way up to 1366, from 1 to 2 to 4 to 8. All the way up, I'm seeing the sequence that I was expecting to see. So that is the big, understanding how that works when it comes to using and making sure all the variables. There's a lot of code here, right? Like, we're not used to seeing this much code to get something done. What are we up to? Like 80 lines of assembly language code? Some spaces in there and such. But definitely a little bit more than we're used to seeing. But that pretty much covers everything I wanted to cover for this homework assignment. And again, all of this stuff is based off the activity. So, and the key take home is it was pretty much a pure translation, except until the end where we had to work out and go, why wasn't this thing working? And we figured out that functions are using the EBX register and the main is, and they have to play nice. And that kind of comes back to why we do the pushes and the pops on this end. Because we need to share these registers across functions, across main, across all the other functions. Functions call other functions. It gets, this is as pretty much kind of as simple as it gets compared to, code that we write in the real world. So, so it's one of those, we need to make sure that registers don't get blown out along the way. Otherwise, of course, as we just saw, some things can go wrong. So as always, if I misspoke, said something a little bit that I wasn't supposed to say, just like that sentence, you can call me out on it, comment below, or email me at swardb@cod.edu. So as always, thanks for sticking it out with me. Have a great day, everybody. We'll see you next time.